Hello there. Today I'm going to solve 13th January 2020 question paper for chemistry, and it is a unit 4, and the section A first question is, this question is about 4 organic compounds with 5 carbon atoms and different functional groups like 1, 2, 3, 4, 5 carbon atoms but different functional group like this, like aldehyde, this is a ketone, this is the amide group, like these 4 different groups. So the first part question is, which of these when mixed with water produces the solution with lowest pH? The lowest pH means when we will add water in these compounds, so the product will be acidic. That's why the solution will become acidic solution. That's therefore the pH will be reduced. So when we add water in these 4 compounds, the first compound will only make acid, because when the water added in this, so water OH minus will attack on this carbon, because this carbon is most delta positive, because the chlorine is attached to this carbon and this oxygen. So here is also oxygen, here is also oxygen, here, but this is the nitrogen is less electronegative than chlorine, so the most delta positive will be here, so the fastest will be this one. So this will make carboxylic acid, therefore the option compound 1 will make the lowest pH. Now B part, which of these react with ethylamine, this is the formula of ethylamine, to form N substituted amine? So once again, the ethylamine has the lone pair, it means it's an excess of electron, it has the extra electron, so it will give this extra electron to that compound which have the electron deficiency. So once again, this carbon has the most delta deficiency, the most, because this carbon and this chlorine and oxygen takes the electron from this carbon towards their cells. Okay, therefore this carbon behaves like most delta positive, so ethylamide will attack on that compound, the first compound, to form N substituted amide. Okay, now the C part, which of these reacts with iodine and sodium hydroxide solution to produce pale yellow precipitate? This is nothing but this is a test for iodoform, and iodoform has one condition, that it will react carbonyl group that should have one methyl attached to it. So only the option C has one methyl group to C double bond O, otherwise none of them have this group. So therefore compound C will show the positive iodoform test and makes pale yellow precipitate. Now the question second, which of these molecules can rotate the plane of plane polarized light? The plane of PPL, okay, a plane polarized light means carbon must be chiral carbon. Okay, any compound should have at least one chiral carbon atom. What is chiral carbon atom? It means the carbon is attached with 4 different atoms, A, B, C, like this. So we have to check all these 4 compounds which carbon has all 4 connected to all 4 different compounds. So here this carbon is connected to 2 hydrogen groups, so it can't. This carbon is also connected to 2 oxygens. This carbon is connected to 2 hydrogens and 2 oxygens, so this is also not a chiral carbon. This carbon is connected to hydrogens, and this carbon is connected with this different compound CH3, Cl and C. Okay, if I make like this CH2, Cl and this is Cl, or this CH3. So if we say this carbon is attached to 4 different groups, like Cl is the first, COOH. COOH is a different group, CH3 is a different group, and CCl or H2 is a different group. So this carbon has one chiral carbon. Okay, so it can rotate the plane polarized light. Therefore, so the C will be the correct answer for this. Now the question third, a polymer is prepared by reaction between hexane diol dichloride and the hexane 1,6-diamine. So the reaction type, when this reaction occurs, so which type of, or what type of polymerization occur? So in this type of polymerization, condensation occurs. Okay. Now the fourth question is compound. This compound reacts with excess sodium hydroxide solution. What is organic product formed when the reaction? Okay, when this reaction will occur, so what product will be formed? So this is the excess, means if only NaOH was there, so one acidic, this is a base, and one acidic hydrogen will remove here from here, and it will form this one. But we have taken this in excess compound, means it can remove all acidic hydrogens, so it can remove this hydrogens also, it can remove this hydrogen also. So the from here hydrogens Na both side Na will be attached, so the product answer will be A. Okay, answer will be A. Now the fourth, then fifth. Which diagram shows mechanism for the second order reaction between one bromoethane and potassium hydroxide in aqueous solution? So the diagram 1. In diagram 1, bromine is removed. Okay, bromine is leaving, and then OH minus is attacking on it. So it's a two-step reaction. It's a two-step reaction. It is SN1, because second order reaction is single step reaction, and it is two-step reaction. Diagram 2, Br is removed, and now the positive is attacking on negative. This is not possible. Always nucleophile attack on electrophile. Okay, but here electrophile is attacking on nucleophile, so this arrow is wrong. It should be like this. Now the diagram 3. In diagram 3, it happens in single step, because base OH minus attacking, and at the same time Br is leaving. So it's a single step reaction. When OH will attack, when this bond will be formed, so the CBr bond will be breaking. So from here we can say this is SN2 and it's a second order reaction. So the diagram third will be correct one. Question 6. Which of these reacts directly with ethanoic acid to form ethanoyl chloride? So the reaction, which of these reacts? So the only reacted with potash phosphorus 5 chloride, PCl5, is only that can make this as ethanoic acid to ethanoyl chloride. It's a source of chlorine. We can say this is a source of chlorine. It breaks down in PCl3 and Cl2, so therefore it can react to and make like this compound. Now question 7th, which of these changes has the largest increase in entropy of the system? Okay, so it's solid to liquid. No, entropy of gas is greater than liquid and liquid is greater than solid. So it is converted from solid to liquid, liquid to gas. So I guess B is the correct answer because it is converting into gas and gas has highest entropy. Now question 8, equal amount of W and X are mixed and allowed to reach equilibrium. Okay, value of equilibrium constant Kc is equal to 4.85. At equilibrium the mixture will contain almost all Y and Z, almost W and Z, X and Y and Z, but there is less X and Y. No, this reaction is going forward because the Kc is greater than 1. So the more quantity will be Y and Z. So X and Y all will be there, but the more quantity will be for Y and Z, and less will be W and X, because this will be react and this will form, and it's this going forward direction. So the quantity of Y and Z will be higher than W and X. So the 8 1, the D answer is correct. Now question 9, what does X represent on the diagram? So this represents sum of enthalpy changes of changes of hydration of gaseous ions. These are gaseous, become solid when these, and after solid they become aqueous. So the sum of enthalpy changes of hydration of the gaseous ion. The gaseous ion becomes hydrated. So that's why it's a sum of change of hydrations. Now question 10, how are 20 centimeter cube of 0.05 mole decimeter cube of H2SO4 aqueous and 20 centimeter cube of acetic acid alikes both solutions? So as we know, this is the strongest acid and this is a weak acid. Therefore, in front of strong acid, it will behave like a base. So it will behave like a base. So which will be same pH? No. Have the same total concentration of ion? No. Have the same total number of concentration of negative ions? No. Require 20 centimeter cube of 10 of the same NaOH to complete the reaction. Yes, because half will react to this and rest of half will react with NaOH. Okay, now which two solutions both of concentration 0.1 mole decimeter cube have been used to produce this titration curve? So this is initially when there is no base was added, so it was acidic and it is strong because the pH is very low, so the acid should be strong acid, and after becoming neutralization point at 7, and if we will add little more base, the pH is suddenly increased to 14. It means that base we have used, that was also a strong base. So it's a reaction between strong acid and strong base. Okay, so strong base means KOH. Ammonia is not a strong base, so we can uh, cross these two because these are wrong. So A and B can be correct. So from here, this is a strong and this is a weak acid, but we have seen here the base is strong, so we can say uh, this can be acid can be weak. So from here we can choose option B, not A, because so now question 12, a solution of sodium hydroxide of concentration 0.008 mole per decimeter cube has pH. We have to solve this. So it's a base, so the ion will be OH minus, and we can say the concentration of OH minus is this. So pH will be minus log the concentration of this. After calculation we get 2.09, and we have to find out the pH. So pH is 14 minus 0.09, so it will be mm, it will be 11.89. Okay, it will be 11.91, sorry. So it is in between this. So 12th answer is C. Now question 13. A student carried out an experiment to determine the equilibrium constant for reaction to form ethyl ethanoate from ethanol and ethanoic acid. Okay, this and this. The different amount of each substance were added to conical flask, each containing 0.2 centimeter cube of 1 mole per decimeter cube hydrochloric acid. So conical flask 1, 2, 3, the volume added, HCl, the water. Okay, this all the volume added we given in this table. So the flask were then stopped and left for a week to reach equilibrium. Each mixture was then titrated with 0.1 mole per decimeter cube sodium hydroxide in each flask. Was equilibrium approach from the right hand side of the equation. Okay, so flask 1 only, flask 4 only, flask 1, 2, 1 and 4 only. Okay, so in which flask was equilibrium approach from right to? Okay, question 14. A reactant Q is converted into two products. Which of these graphs shows that this reaction is first order with respect to Q? So as you have already learned, the first order graph with respect to Q, so the only graph that is correct is the third one, that is the graph C. Okay, now question 15, which this question is about the kinetics, the reaction between nitrogen monoxide and oxygen. The rate equation for the reaction is rate this. So which statement is not correct? Okay, so the reaction is third order overall. So the reaction is third order overall. Yes, 2 plus 1, this is third. So the unit of the rate of reaction is decimeter cube. Yes, mole decimeter cube per second. The rate of reaction increases when the pressure is increased. So yes, the 2 plus 1, the left side, the number of moles is higher than the right side. So if we will increase the pressure from increase, so it will the reaction will go from left to right. So this one is also right. So when the concentration of nitrogen monoxide doubles, the concentration of oxygen quadruple. Okay, this is doubled, so it will be 4, and it is quadruple. So okay, oxygen is quadruple the rate, increased by which factor? So it is increased by 16 times, but it is 8. So this one is the wrong, and that is actually our right answer. So D. So what are the units of rate constant K for the reaction? So as we know, the rate formula, the rate is equal to this. So we will change mole decimeter cube per second divided by the mole decimeter cube minus, okay, whole square, and multiple the mole minus mole decimeter minus cube. So after calculation we get decimeter cube to decimeter raised to 6 dm raised to 6 mole minus 2 and second minus 1. So the D is the correct answer. Now C part, an experiment was carried out using 1.1 into 10 raised to minus 2 mole decimeter minus cube of oxygen and some nitrogen monoxide. The numerical value of the initial rate and the rate constant were this. What was initial concentration in mole per decimeter cube of nitrogen monoxide used? So initial rate was this K, and this was nothing but concentration of monoxide, and that's whole square, and this after calculation we get the concentration of nitrogen monoxide as 1.31 into 10 raised to minus 2 mole per decimeter cube. So the correct answer is A. Now section B. Okay, so section B 16, compare ethyl 3-oxobutanoate, which is used in food flavoring, has the formula this. The high resolution proton NMR spectrum of this compound is this. It is given to us. So we have to tell which group is this. Identify which group of hydrogen atoms responsible for each peak in the spectrum by adding the labels X, Y, Z. Appropriate part of this displaying matches the letter in the spectrum. So okay, why? Because there is no neighbor hydrogens, so only one peak is there. So this will be Y. X, and this is X because there is also no peaks here. Okay, but W and Z is here. In case of W, there are three more peaks, 1 2 3, and this is why, because it has three neighbor hydrogens, 1 2 3, and in case of Z it has two peaks extra, so it is because of these two hydrogens. So the label is, this one is Y, this one is X, this one is W, and this one is Z. So explain the splitting pattern of each of the peaks at this and this. So why the pattern is split at 4.2 ppm due to adjacent CH3, and in case of this due to adjacent CH2. So we have to draw the isomer of ethyl 3-oxobutanoate that contains carboxylic acid as well as ketone, and so this is the only possibility we can make. This is the group that shows ketone group, and this is carboxylic group. So now question 17, Compare and contrast the reaction of propanol and propanone with one oxidizing agent, one reducing agent, and 2,4-dinitrophenyl hydrazine. Okay. In your answer, include any relevant observation for the reactions you discuss and equation for any reactions classified as oxidation using this, and for okay any reactions classified as this, and for the oxygen from oxidizing agent. So what similarities? Both can be reduced by ALI, ALH4 or NaBH4. Both reacts with 2,4-dinitrophenyl hydrazine to form a yellow precipitate. What are the differences? Propanol forms a primary alcohol, but propanone forms a secondary alcohols. Okay. Propanol reacts with Fehling solution, but propanone does not react. And the reaction is for this. This is a aldehyde and this is a Fehling solution, and it reacts to form this. And the color change when the Fehling reaction, the color changes from blue to red. Question 18. The rate constant for the reaction to convert cyclopropane to propene was determined at 5 different temperatures. Okay, so the temperatures are 1 okay 719, 746, 791 or 840, 889. So 1 upon T, 1 upon T can okay, this is a reverse of 1 reciprocal of this, so we can solve this. Okay, so 1 upon 1 upon 840 is comes out 1.19 into 10 raised to minus 3. Okay, and the rate constant when we will solve this ln, so we will get minus 6.4 values. So the table is completed. Now plot a graph against ln x ln k against 1 upon t. So here the graph we can draw. Okay. Question 19. This question is about halides. Silicon tetrachloride SiCl4 is used to manufacture optical fibers. It can be made by the reaction of silicon carbide SiC with hydrogen chloride using a crystal of nickel 2 chloride SiC plus hydrogen to form this. It's an exothermic reaction. Standard molar entropies are given. Substances are shown in the table. Okay. Calculate the total entropy change Ts for the reaction at this temperature using information given. Include a sign and unit in your answer. You should give the appropriate number of significant figure. So as we know, the entropy of the system is entropy of product minus entropy of reactant. So the entropy of product is product is 8.88 186.2 plus 239.7 minus 16.5 minus 186.8. So after calculation, the entropy of the system is minus 337.8 joules per Kelvin per mole, and this entropy of the surrounding is minus delta H upon T, and minus and minus because the reaction is exothermic. So after calculation we get plus 2.118 kilojoules per mole. So the total is system plus surrounding. So it's a minus plus this, and this entropy of the total entropy is plus 1780 point. So you can make it kilojoules or you can leave in this also. So now use your answer from part A1 to calculate equilibrium constant for reaction at this. So total entropy total is equal to R ln K. So ln K is equal to delta S total upon R, and as we calculated this 1780.2 divided by 8.31 in joules. So after calculation we get 214.22. Now to solve ln k, to find k will be e raised to this, and after calculating we get k as equal to 1.18 into 10 raised to 93. Now B part, following data can be used in a Born-Haber cycle for calcium iodide. Okay, enthalpy change of atomization calcium is this, first ionization energy of calcium is this, second ionization energy of calcium is given. Okay, enthalpy change of atomization of iodine is given, electron affinity of iodine, and lattice energy of calcium iodide. So this is the table and we have to mark. So A, and what was A? A was enthalpy change of atomization of calcium, correct? So this is a D, and what is happening here? Okay, here it is becoming calcium plus. So this should be B, and B what? First ionization energy of calcium. So the first ionization energy of calcium, and the reaction will be this, and C will be here because it's a second ionization energy of calcium, and it will be this, and after this E will be what? These two electrons will taken by the iodine, so it will be electron affinity. So E is electron affinity of iodine. Iodine takes these two electrons and become calcium 2, calcium Ca plus 2 gaseous and 2I minus gaseous. So after these, the reactions occurs with lattice energy of these two. This is F. So we can mark all these. Now the forward reaction delta F is like equation is this minus, so the forward reaction is exothermic heat will release. Now section C, question number 20. This question is about ethanoic acid and some of its compound. Three students ABC carried out an investigation to determine the amount of isomyl acetate, an ester of ethanoic acid, in a banana food flavoring. They hydrolyzes the ester with excess sodium hydroxide solution, this with NaOH to form this. The amount of sodium hydroxide remaining was determined by titrating the reaction mixture with hydrochloric acid. Give the systematic name of isomyl acetate. So the systematic name of this compound is 3. So see the structure here. So it's a 1 2 3 4. So at 3 there is a methyl group attached there. Okay, and it's a butyl. So 3 methyl butyl and ethanoid. So this is a systematic name. Now the B is, second part is 6.06 into 10 to minus 3 moles of sodium hydroxide react with ester present in the flavoring. So we have to calculate the percentage of mass of ester in food flavoring. So molar mass of ester is 130. So mass will be this much moles into mr, and moles is given to us, and multiply with mr we get this much. So percentage of ester present in the food flavoring is, total mass was 1.07, and the mass of ester is this. So after multiplying to 873.6 percentage was present as a mass in food flavoring. Okay, 73.6 percentage of ester present in a food flavoring. C part, third part is, the student used 25 centimeter cube of sodium hydroxide solution with concentration of this for hydrolysis. Calculate pH of the reaction mixture when hydrolysis is completed. Assume total volume is this. Ionic product of water is given to us. Okay, so excess moles of NaOH. Excess mole of NaOH is this, and already we have given 6.06, so this is the excess moles of NaOH. Okay, now the concentration of excess NaOH is what? So this is the moles and this is the volume, so moles divided by volume in decimeter cube, so we get this as concentration of NaOH. Now this NaOH, we need to find out the pH of the solution. Okay, pH of the reaction mixture when the hydrolysis is completed. So now pH is nothing but 14 minus POH. So 14, and POH is minus log of this. After calculation we get 13.9 as pH. So the fifth part, describe how sodium ethanoate in final reaction mixture could be converted into ethanoic acid. Add more hydrochloric acid, HCl equals. So B, ethanoic acid can be used to form buffer solution. Calculate pH of buffer solution formed when 50% of ethanoic acid with concentration of 0.15 mole per decimeter cube is mixed with 30 centimeter cube of sodium hydroxide solution with concentration of this. Ka for ethanoic acid is this. So moles of NaOH is must be equal to the moles of acetate, sodium acetate ion. So we need concentration. Okay, this is the concentration and this is the volume. Volume multiply concentration will gives us the number of moles. So 4.26 into 10 to minus 3 moles we get. So excess moles of acetic acid is 50. 0.05 into 10 is to multiplies 0.15 and minus this, so the excess of moles we will get 3.24 into 10 raised to minus 3 moles. So the concentration of this is nothing but here we get 50 plus 30, so total volume is now 80. So this volume is divided by 80 centimeter cube, but we have to convert it into decimeter cube, so we will divide with 1000, so it will be this, and after calculation we get the concentration of acetic acid is 0.0405. Now concentration of sodium acetate, and the mole of sodium acetate was this, and divided by this, so we get 0.05325. So of ratio is this. Now concentration of H plus, the concentration of H plus is this. Okay, 7.10 is to minus 5 multiplies the ratios, and we get 1.29 into 10 is to minus 5 moles per decimeter cube. And now we will calculate pH. So pH formula is pKa minus log acid upon base. So pH is, and now this pKa can be written as minus log Ka, and minus log the ratios values here. So the after calculation we get this as 4.769 and this as minus minus plus, so 0.118. So after calculation this is 4.887 and we can nearly take this as 4.89. So thanks for watching video guys. Thank you. If you like it, please like and subscribe our channel.